Another way to interpolate is to interpolate to a vector surface. It doesn't necessarily have to be a raster. In this case, you are specifically talking about a tin. So the tin is slightly different to a raster in that it's very useful for terrain analysis using a highly varied terrain, highly varied gradient and the like. And the raster is the more common one actually to use, but not always the most suitable one. So how do you find it? You can simply search for tin in your search toolbox or search window, or you can open the 3D Analyst tool extension. This again is a paid for extension, so if you don't have it, you need to go to Customize Extensions and activate it. But once you have it activated, you just go to the tool itself, and you want to work with the tin toolset. That's part of the data management one. Now here you want to create a tin, so you are going to give it the input elevation raster. Again, here it's going to be it's not the elevation raster, sorry, it's going to be the input points. So you have to have elevation points that you can use to create the tin from. If you don't have these added, you'll have to navigate to your data source to actually add these in. For example, if you have a relief points that you want to work with, for example, those are shown in the screen now, you can use these to actually interpolate to the tin or the triangular irregular network. That's what it stands for. It uses Delaunay triangulation to create its non-overlapping triangles or topologically correct triangles. So you open the tool, you put in the input feature class. It normally assigns the height value field automatically if it's correctly defined. Here it is, height. The coordinate system is optional, but if you do know what it is, in this case it is LO27, it's always a good thing to put it in, and you can just accept the defaults. What it's going to create is a vector surface that gives you a 3D or a pseudo 3D view of the area as well. And you can see that here. So as you can see, I have various height values based on my input relief points. The colors aren't the best because obviously at 900 meters this doesn't mean that this is actually a dam, which the blue color implies, but it uses a standard color scheme, so this can be accepted for now. And as you can see, we have a ridge towards the south and the bottom center of the image. We again have a little bit of a heightened elevation towards the northwest, which in this case is actually Pilansberg, and we have quite a big plain that is fairly level where the gradient doesn't change too much in the central portion of the image and also towards the northeast of it. And that is how you would create an elevation surface that is a vector surface. So it's actually not continuous. This is actually a discrete data file, and you can see the individual triangle outlines here. You can see them here. They are actually clearly defined. So it's not a continuous surface. It uses discrete objects. If you compare that to a DM, you'll see that the DM has those very symmetrical cells, grids of rows and columns, and the tin has those irregular placed vector forms that are triangles. But both are very useful for terrain analysis.